Measure the height of 13-year-old girls. Okay.
That one is
Considered as
continuous.
Continuous. So as you can see, wow, you see so many 13-year-old girls can be 1.72, 1.7201, 1.72. It's like a lot. It's a whole. If then because the number of significant figures can be so many. Right. Recording the timing of 18-year-old boys.
That one is continuous.
Continuous also because you see 30, you see can have a lot. It can be a lot. It can be a lot. Yeah. So how about the collecting the lecture test marks?
That one is discrete random.
Can be discrete. Can be discrete. So can you list some? All these are what we call like random variables. Can be discrete, can be continuous. So example one, haven't thought about it.
But then can random variable be decimal?
Can continuous. So example like what you're studying now, the normal. Correct? Yeah. So but it's continuous.
So discrete is whole number.
Discrete mainly we cannot really say it's whole number. Example, how to say I define that my experiment only got 10 outcomes. Can be 1.1 cm. Maybe I'm counting my fingernail. My fingernail only got 1.1, 1.2, 1.3, 1.4. They only got this. I want to cut into only 10 sizes. Cannot be anything. I mean 1.1, 1.2, but the fact is can be decimal as long as it's countable. So it's countable or infinitely countable also can.
Discrete is infinitely countable.
Countable or infinitely countable?
But it is not countable.
This one not countable.
Okay.
Then okay, so you see, so first one, determine whether each of the following. C have copy. C copy now.
Oh, but I have already in my.
Really? Okay.
I didn't go for
which one?
this one. From 5 onwards.
From 5 onwards. From 5 onwards.
This one I should understand.
You don't understand. Okay.
Wait, probability. It means 0 hearts obtained, 1 heart, 2 heart.
Correct. So you know that probably there are 4 kind of questions. Can be P&C, got Venn diagram, got tree diagram, or table outcomes. So these are the ways that you can approach. So sometimes maybe the probability too nature, you think about maybe counting more ways that something happen. 2 cards are drawn at random. Okay, for a pair of cards. Let X denote the number of hearts obtained. So one deck 52 cards, right? Got 13 hearts, right? So it's 13 hearts. So got 39 non-hearts. Okay, so first one we think about maybe you obtain 0 hearts. 0 heart means out of the 13 hearts I choose any no?
No.
Don't choose out of the 39 I choose 2. Because I choose 2 cards. So how many ways? 39 choose 2. Over the number of ways I can choose 2 cards, which is 52 choose 2. So this one give me 1 probability. Then this one, so this one is 0 heart. This one is 0 heart. This one is 1 heart.
1 heart and 1 non-heart.
1 heart and 1 non-heart. This one is 2 heart.
Okay, I got it.
Order matter? Order don't matter. You just want
choose.
Cannot simultaneously. Like that. So or you can say this this one is like in the GH method. 39 over 52, 38 over 51. I select 1, then I left with 51 cards. Then I select the. Capital welcome tree. Capital W welcome tree. You have my IC number? 8431263J.
Wait, 84
31 263J. Then my password is capital W welcome tree. Welcome tree.
Now I know.
don't need.
Only no need right? Time out. Cause I don't need. I remember I can just get in just now. Okay. Then so this is so PDF probability distribution. You just remember it distributes. It show you the distribution of the probability. It's a function that show the distribution of the probability. Then you attach it to its value lah.
Okay.
Then after that will be question 4. Question 4. How's question 4? The thing is, okay, are you
Like that.
y equals to 1 plus point y equals to 2. If you're curious, maybe you can also find y equals to 3.
Equals to. Is it?
You don't know what is it yet. So but you copy paste all this. Okay. a 3 over 4 power 1 3 over 4 if you don't put a dash become 3 choose 4 okay then 3 choose 4 will not make sense okay then 3 over 4 power 2 there okay then like that how so you see anything or anything you can take out
yeah you can take out A
okay you take out A right because A will not help you much okay then 1 plus 3 over 4 plus 3 over 4 square correct okay what kind of GP is this sum to
infinity
sum to infinity sum to infinity you remember the formula
is it
yes correct A over 1 minus okay so what is A
is it
the first term the first term
is
1 correct so what is R
the ratio
the ratio is 1 minus 3 over 4 correct
why is it 1 minus 3 oh yes
R 3 over 4 right yeah then okay so this is equals to this whole thing should be equals to what
1 1 1 1
this is all the probabilities in the world that you're adding right so it should equals to 1 so equal to 1
1 minus that's 1 quarter is like that right
4a equals to 1 correct then a equals to 1 quarter
yay okay
yeah so equals to 1 so 4a equals to 1 and a equals to 1 quarter okay so you recall that sum to infinity equals to a over 1 minus r okay okay
yay I not stupid
okay question 5 question 5 okay question 5
Thank you. I got it.
okay thank you proposition x less than equals to 2 because of cumulative cumulative so you know that
so
this
I
one
must take
is equals to 4 over 9
David.
those that you have found right then what how to
I must find f equals to 1 right?
yes you can so what is f equals to 2 you can take
f2
f2
minus f1
yes f2 minus f1 okay or in our sense in our lingo is quite probability of x less than equals to 2 minus probability of x less than equal
mister, that's
1
your lingo
okay ya lah
which is 4 over 9 wait oh no
depends
can 1 third 'correct this is correct right
yeah correct
okay got it yes
and 1 third yeah correct okay then next one
let's go
equals to 1 third okay
oh yes this is the one I didn't count
wait you haven't do
Yes, I have.
the question tell you already capital X will take values 1 2 or 3 then you know the probability of x equals to 2 you found already which is 1 third you
yeah
can
so
probably
1 minus right
yes
nine four five wait
4 over 9 4 over 9 so it's 2 over 9 or 3 over 9
eh
this one the one you're taking is the cumulative is x less than equal to
oops
ya lah so 5 over 9
okay
so you must know the difference between PDF and CDF CDF cumulate so you sum everything up to that value PDF is at that particular value
okay
okay got difference so the main thing for the question 1 to 6 you must know how to come up with a PDF how to draw a CDF and the difference between each of them
okay
yeah that will be the the lecturer expected us to read is that he expected us to read this that from our lecture notes the expectation of x given that it's discrete is the summation of all the value of x together with its probability okay so for a discrete random variable, the first definition that you will learn is that the expectation is the summation of the probability of x together with its attached x value for all the x. So give you an example. Okay, so example, throw a dice. Okay, throw a dice. Probability of x can be 1, 2, 3, 4, 5, 6. The probability of x, probability of 1.
1 over 6.
1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6. Okay, then what's the expected mean? What is the mean? Because we don't really have a true mean, because it can be anything. What's the expected mean?
1 over
6 times 1. Okay, see, probability times its attached x value. Probability of x. So it's like this part here, actually, it's like 1 multiplied by probability that x equals to 1 plus 2 multiplied by probability of x equals to 2
plus
3 multiplied by probability of x equals to 3 plus 4 multiplied by probability of x equals to 4. Correct? So, yeah lor.
Okay.
Example. So this is how you calculate. So basically it's just like example 1 times 1 over 6 plus 2 times 1 over 6 plus 3, a bit like scalar product, plus 4 times 1 over 6 plus 5 times 1 over 6
plus 6
correct, and this one will give you the answer. Okay, so this will give you the expected mean. So expected mean in statistics is like to give you, it's really like finding the average, right? To let you know roughly what you get. So example, say you give a luck, maybe you go gamble or something like that. Then the probability of you getting $0, maybe you lose that, is maybe the probability is 0.99, correct? Then but the probability of you winning $100 is 0.01. Then will you still play the game? So people will say, oh, very hard to know whether my chances of winning high or low. So what they do is they use a probability. They use expected mean. What's my expected mean? What's my expected winning? So expected winning is what? 0 times 0.99, for example, plus 0.01. Okay, or plus 0.01 times $100. So what's my expected winning? Only $1. Or even worse, I can say there's a 0.99. Either you lose $10, maybe you lose $5, example, or 0.01 you win $100. So this one times minus 5. You can see my expected winning will be it's like negative. Will you still play this game?
No.
You won't play because high chance you will lose. Expected means I will lose. Negative
because
number.
I cannot gamble.
So okay, cannot gamble. Okay. So example. Okay. So this is the definition of the expected mean. Then with that, okay, so discrete random variable, so you need to know expectation, the mean, as well as the variance. This one is the PDF or CDF? PDF because equal. Okay, so this one is the PDF function. R can take on 1, 2, 3, 4, 5.
Yes.
Okay, I want to find the value of A, and hence the probability of x less than or equals to 2. This is just A R power n over 1 minus R. Okay, where n is the number of terms, R is the ratio. This is just a GP.
Okay, next time can I go toilet?
Go.
Thank you.
Okay, ready? Okay, so this one, right? Okay, so you see, this one is sum to GP. Then from here, you know that all the sum to probability will give you 1. Correct? So that's like all the basis of everything. That's one of the thing that you will come up with. Then you find A. A find, right? Then after that, this one you find probability of x less than or equals to 2.
1 plus 2.
1 plus 2. Right? 1 plus 2. And 1 plus 2. And therefore answer come out here. So here you need the value of A. So once you find the value of A, right?
Then
so
just sub in.
Just sub in. Then 1. A power half. 1 half power 1. So this part is like half power 1. Then it's like half power 2.
Got it. Okay.
Then after that, find the explanation of x. So this one will be based on your formula. So I mean, at this point in time, because you haven't, they haven't introduced, so maybe like some people don't know, but actually, like, yeah, by right, we're supposed to read the lecture notes ahead. I mean, theoretically, you read ahead and you know how to do the summation or probability of x. You know, that's all. So here, I mean, okay, you see, this one is the A, right? A I put outside.
Yeah.
Doesn't really help me, so I sum. This portion again, you can use just calculator or actually it's like a GP. Because I sum half then from 1 to 5. It's a GP because term is half, number of term is 5. Yeah.
Okay.
Yeah, so that's for this part. Okay.
What is this?
This one. Oh, there.
Oh. At home now.
Huh?
At
Now.
home.
No. Do now. At home do nobody help. Cover it first.
Okay.
EX, remember, just based on the formula. All I need to do is this formula. Summation of x with the probability that x equals to x. This one.
Yes. 1 plus 2. So it's this one, right? It's 1.
Yeah.
Must I write the like that, right?
EX. Yeah, you can write. No. State the intention of your working. The answer will come out quite nicely.
2.
2. Okay, good. How about E1 over x? So you see, like EX, right? EX, right? Then I put this, right? How about E1 over x? E1 over x is just like I sum. Don't have 1 over x. I don't have also 1 over
How many
x.
parents letter are you allowed to letter? Sasha?
3.
How you know? How you know?
Okay. Theoretically, if you read the lecture notes, so I mean, they will tell you that E of AX, right, is equals to A of EX. Okay, this one. Okay, then what is the expectation of a constant? What's the expectation of B?
0.
That's variance.
Oh.
Expectation of B. What's the mean of $100? If I say it's $100, it's just $100. It's 100. What's the mean of 100? It's just $100. Right? It's just B. Right? So the expectation of AX plus B is just the A of EX
plus EB. Okay.
Yeah. There's a way to prove this, but to read, go to your notes and read it. Okay. Otherwise, just remember, expectation of constant is just a constant. Variance of a constant then is 0. You know? 8. Okay, correct.
Okay.
And then this is the part you read. Okay, let me tell you. Just verify, correct?
Yeah.
Okay, good. Next. Example 9.
So this is equal to
This one is the definition of variance. Variance, right? Okay. It is the expectation of the square okay, one time. Okay. Deviation is the expectation of the squared deviation of a random variable from its mean. So it's like I'm finding a distance between my mean and my random variable. I square it. Okay. And the standard deviation measures how far a set of random values are spread out from the mean. So if this value is very high, if this question, I mean this particular variable, right, the deviation is very high. Okay, it means like the variance is very high. So variance, so variance x, usually we call it sigma square. Okay, standard deviation is just sigma. So you might say as normal distribution. So this one, right, if the variance is very high, means you think in English it varies a lot. It varies means it can be vary a lot. Means the deviation can be very big. Variance is small, standard deviation is small. That means everybody, all the values data are quite around the mean. Yeah. So this one, right, can be seen in this way. Okay, so I believe in JH, when you study it, you will probably see something like that. And this is also the same as EX square minus EX whole thing square. Okay, you know why? Okay, so very simple. Okay, so EX square, right? This is the EX minus mu, correct? This one by the definition, this is the same as E of X square minus 2X mu plus mu square, right?
Yes.
This is the same as E by our definition of expectation minus E of 2X mu plus E of mu square, right?
Yes.
This is the same as the expectation of X square minus 2 and mu are constants, right? Correct?
Oh, yes.
2 mu is just like numbers. Okay, then this one, what is E of mu square? E of a constant is just?
E of a constant is just the same thing.
The constant itself, right? What is EX? EX is just? What is EX? Just mu. Mu. EX just mu. EX just mu, right? Mu is the mean, ma. So I always put mu as the mean, sigma as the deviation. So you remember this one is always mu?
EX is a mean.
It's a mean, right? Because usually, for example, X, every time we do this, we always do this, right? Mu sigma square, normal distribution. Mu is a mean, right? So here, this one is, can I say it's 2 mu square plus mu square? I combine these two, what I get?
Minus 3 mu
Minus,
square.
minus your head. Minus 2 plus 1.
No.
Minus 2 plus 1.
Plus.
Minus or plus?
Minus mu square.
Minus mu square. Minus mu square is the same as minus EX square, right?
Yes, okay.
Understand? So
Yes.
this one is this. Okay, good. So this is the formula that we will apply. So meaning, right, this is like I take probability of X times X square, probability of X like whole thing square. So okay. Then so it's so that's why this one is brought to you. Yeah.
Can.
Okay. Then so variance of A is equal to 0. Why then? Because variance of A, think about it now. This is like variance of A, right? It's the same as E of like A square minus E A whole thing square. What's E of A square?
A
Square. What is EA square?
A square.
A square. 0? Okay, that makes sense. Okay, so now very legit. Okay, so variance of AX, variance of AX, this is just E AX square minus E AX whole thing square. Right? This part is also A square EX square lah. Can see this part. Okay, this part is the E of A square X square, right? A square is a constant, right? Pull out, right? So it's A square EX square, right?
Oh, okay, yes.
This part also minus E A square. This one is really wrong. Okay, so this part is just EAX, right? It's just A of EX square, right? It's the same. A square EX square, right?
Yeah.
Correct? A square, yeah, correct. Okay, so what do you see now? If I take out A square, can I take out A square?
Can.
This is E
Oh,
of,
then you bring the variance.
yeah, correct? This one's the variance, that's why A square.
Okay.
Yeah, so you interested to know this? I think like Miss Ling, when she lectured this, only 10 people were interested to find out. So I just tell you for you. Okay, so some people, you just like you go to tuition center, they just tell you, you memorize this, then you just square variance. So with that, variance AX is equals to A square variance X. Okay, yeah. This is very important. E of AX plus B is equals to A of EX plus B. Commonly, we use expectation as mu. We use variance as sigma square. Okay?
Can.
Okay. With that, all this should be okay now.
Okay.
Then okay, try 11. Think about it. This is like I take 4 choose 2 over 7 choose 2. This is just 4 over 7. 4 choose 2 is okay. 4
what is that?
choose 2, correct? 6. 6. 7 choose 2. 7 choose 2. 21.
But that's not I say correct or not?
Yeah, so it's just 2 over 2 over 7. So it's the same as 4 over 7 times 3 over 6. Correct? Okay, you try this one.
Yeah, correct.
Same, okay.
Oh.
There. So there are a lot of ways to see. I can see as a P&C, to count number of ways, I can use probability law. Probability then will be like your GH method. I take out then no replacement. Then let's say if I want one rate means what? Can means I can say out of the red, right, 3 choose 1. Out of the white, 4 choose 1. Then over 7 choose 2. Order don't matter. The key thing is we just want 2 this. So this one, although the number looks very innocent, but actually got a lot of thinking behind it. Okay, variance of ax minus by is also the same.
So whatever it is, I just take it as plus.
Yeah, correct. It's just b square minus y. It doesn't matter. It doesn't matter.
Okay. 0. Right. Yeah.
This one also can show. You just use the formula can show it. Why is it a plus and not a minus? However you do for your topics, because different topics. Okay, so it's different from repeated observation of the same one. So there's a difference. So later you'll see x1 plus x2 is the sum of 2 independent observations. 2x is different. 2x is like twice of the same test. So 2x you because when you do this, right, when you do variance of x1 plus x2, especially you affect the variance sign. This is just variance of x1 plus variance of x2. But you do variance of 2x, right, then it's different. These 2 lecture tests.
2 square times variance.
Yes, 4 variance. There's a difference. There's a difference, so you must take note.
Probability of xy multiplied by xy.
Multiplied by xy. Xy is like the product.
Yes.
You know like that. You know, at first it was like this one. X probability of x equals to x, right? So now it's like xy and probability of xy and xy, right? Right. So you think about it now. Yeah, independent means what? Probability of xy is the same as probability of. Hey, we just did the probability tutorial today. Come on. Probability of x intersect y. A and B are independent, right? Probability of A intersect B is just probability of A.
Probability of A intersect B is A union.
Probability of A. Okay, probability of A or B. A union B. Okay, A.
What's the question?
Intersect B, right?
Yes.
It's just probability of A times probability of B, right?
Yes.
It means x and y happening together. You just okay. So this is just probability of x multiplied by probability of y multiplied by xy. So you can see this part is ex. This part is ey. That's why it's like that.
Oh, okay.
Okay,
Understand.
Yeah. Then this one should be okay lah. Just sum. This one also okay. So it could be with 2, right? X equals to 2. What could it be? It could be that it's a head and I have a 2, right, on the die. It could be that I have a tail, then I have a 1 on the die, right? Compound this thing. Let's say x equals to 3, right? Also can be cannot be twice. It can only be a head and 3. Right?
Okay.
X equals to 4, that means it can be a head and 4. It can be a tail and 2, right? You get the idea. So you slowly